All right, welcome everyone to today's SAT prep session for the Math with Calculator portion of the SAT exam. My name is George, and I am one of the University of Chicago interns at the Education USA Mexico City Center, working remotely from my home in Virginia. And I'm so glad to get to be here with you all today. I would have been accompanied by my fellow intern today, but she has finished her internship, so I will be leading the presentation today. So the purpose of this SAT prep session will be to give you like tips and strategies on what to expect for the SAT with calculator section and how to improve your score when you do take the SAT and stuff like that. But before we get started with the material, I had just a quick little icebreaker question I wanted to ask you all here. You can either answer by unmuting and talking, or you can write it in the chat. I just wanted to ask how you guys are feeling about the SAT math section. It doesn't have to just be with calculator portion, just the math section of the SAT in general.
Well, hello there.
Hello.
I'm Emmanuel.
Yeah, I can hear you, Emmanuel. It's nice to see you.
Nice to see you too. Well, I feel confident in the SAT for this section, calculator and no calculator. In reality, I have been studying for another test. It's more complicated than this one, the GRE, but this test for me is interesting too. I now I understand that this one, the SAT, is more easy than the GRE, right?
Yeah, the GRE is meant to be like a graduate level exam. Well, this is the exam that undergraduate students take for because it's used by colleges as one of their factors for admission. Yeah, Diego, you have your hand raised. You can go ahead and unmute.
Okay. So this is my first session that I attend of the SAT, and I just wanted to know what are we going to see in this SAT math session.
Yeah, in this session, I'll be going over what this portion of the exam will have, question wise and stuff, as well as the type of questions that you may encounter while taking the SAT, and it'll have example problems for you guys to work out, and get an idea of what kind of questions will be on there. But I'll also be sure to list some additional resources for you to learn and practice for the SAT math exam, because there's some other good ones besides what I will be showing you right now. But yeah.
Thank you.
Of course.
I have one more question.
Okay.
Is there a place in which we can access the recorded meetings?
So after the end of my duration of the internship, so after the final SAT prep session, which will be next Monday, my supervisors will be getting all of our recorded sessions uploaded to YouTube, and we will notify people that want the rest of the recordings by then. We have a WhatsApp group for the SAT, for an SAT study group that I'll be showing towards the end of the presentation. So if you want to if you want to get notified when we upload all these SAT prep sessions to YouTube, you can join that WhatsApp group at the that comes at the end of this presentation.
Okay, thank you.
Of course. Anyone else? If not, then we can go ahead and get started with the material here. So the SAT Math with Calculator portion. Well, first of all, the SAT math test in general, which includes both sections with and without calculator, is designed to test students on the areas of math most important in college and career success, which includes algebra and other like high-level math concepts. Now, specifically for the SAT math with calculator, there are a total of 38 questions, 30 of which are multiple choice, meaning you'll get like choices of answers to pick, and then 8 are grid-in questions, which means they're kind of like questions you have to write down your answer rather than like select a choice. So the questions that are on the math test, both the sections with and without calculator, fall into 4 main categories here. There are the heart of algebra, problem solving and data analysis, the passport to advanced math, and additional topics in math. And for all these 38 questions, you have 55 minutes to complete them. I'll be going over the 4 main categories in more detail in the subsequent slides. Right now, I'm just going over the general format of the SAT math test, of the math with calculator test and the math test in general. But yeah. Also, if you guys have any questions throughout any part of the presentation, you can go ahead and raise your hand and to ask your question. So yeah, just raise your hand anytime if you have any questions about what I'm discussing here. So yeah, we're continuing on. So what should you expect for the SAT math with calculator exam? So for this exam, you must bring your own calculator, and you may not use it at any other point in the exam other than the math with calculator section. Otherwise, you may be dismissed from the exam site or wherever you're taking your SAT, and your scores will be canceled. Meaning that any part of the exam that you've completed already will be effectively like gone, like they won't count it at all and they won't score it. So do not use your calculator during any other portion of the SAT. It's only supposed to be used during the SAT with calculator portion. But yeah, so during all other parts of the SAT exam, you should have your calculator like under your chair as you take it. Now, another thing you should expect is that you may run into problems on the calculator portion that may be faster to solve without a calculator. So this is just a point to make I'm making here real quick, that you're not going to necessarily need your calculator for every single problem on the SAT with calculator section. Some might be easy, some might be perfectly fine to solve without a calculator, and that's okay. You can do it like that as well, and it most likely won't make much difference than doing it with a calculator, besides maybe using more time trying to use a calculator to solve the simpler problem. But I'll go a little more into that later. The other thing to note here is that you'll during the math test, you'll be given a formula sheet during both the non-calculator and calculator sections, but these formulas are generally to cover like geometric formulas such as areas and volumes of 2D and 3D shapes respectively. And I actually have it up here so you can see like what kind of formulas you'll be given on the SAT. So you can see in the top part is just formulas for the areas of various shapes, as well as the Pythagorean Theorem, which is the formula of like the hypotenuse squared is equal to both sides of the right triangle squared, so it's like c squared equals the length of b squared plus the length of a squared. And it also shows special right triangles, which may come in handy for solving trigonometric problems that may or may not arise in the exam. But yeah, and then in the next row here, we have various 3D shapes, which in their volumes. I guess here you won't really need to know the surface area for the exam, but that's perfectly okay. So yeah, and it also shows, and lastly, it has some additional properties to know, like the number of degrees of arc in a circle is 360, which means like this rotation here around a circle constitutes 360 degrees. So like this, so like if you can see where my mouse is, if it's given its current position, the angle it would make here is 90, and this would be 180, this would be 270, and that's 360. And likewise, it's states the same fact, but using radians, which is another relevant method of measuring angles, something you may have already stumbled upon or will be stumbling upon if you practice with the resources I'll be presenting shortly. But it says the number of radians in an arc is 2 pi. And lastly, the last property here is also pretty important for any various geometric problems, saying the sum of the measures of degrees of the angles in a triangle is 180. So what does this mean? It means that given any triangle, it doesn't have to necessarily be a right triangle like this one, but the angles that are in between to any two sides will always add up to be 180. So the angle between B and A here, for example, in this right triangle is 90 degrees. And that means the angles between B and C, like this one, and the angle between A and C, those two will add up to 90 degrees. And therefore, all three angles in the triangle will add up to 180 degrees. So that's what it's saying. But yeah. So this is all you'll be given for a formula sheet during the SAT math section. The rest of the types of problems you may encounter, you'll have to know how to do. But yeah. So moving on here. Also, as I mentioned previously, for some questions, specifically 8 on the calculator portion of the math test, you will need to grid in your answer rather than select one of multiple choices. And here's how it works. So for a gridding question, you'll be given four little like spaces here under which you can write numbers. You can either grid in numbers to go in the slot, or something like a decimal point or a fraction line. So for example, in the first one we see here, this one's showing 7 divided by 12. So the way they present that using this grid in question, the grid in answer format here is for the first little column, they grid in a number 7. So that, and then you also have to write your answer in the box. So you not only do you have to bubble the answer in, you also have to write it on these little boxes. So as I was saying, they first bubbled in the number 7 here, followed by the division sign, which is up here. And then they bubbled in a 1 and a 2 for the last two slots of their answer. Likewise, for here for 2.5, the way they bubbled it in is that they started with a number 2 over here and followed by a decimal point and a 5. So not only do you have to bubble in your answer representation here, you also have to write it like manually up here in these columns up just above it. You may notice that this 2.5 is like to the right rather than to the left, and both of those positions are correct, and I'll get to that in a bit because it's also shown towards the bottom. But in cases of certain numbers that are either too large to write, either because like there's a lot of decimal points or because it's like an infinite repeating decimal, such as 1 over 3 or 2 divided by 3. So it shows that there's multiple ways to grid it in the answer box. The first way is just the fraction representation. So they did 2 divided by 3, or alternatively, you can bubble in the decimal number just as an approximation, because you can't bubble in it like more than 3 or 4 decimal points. So the way they did it in these two choices here is they put a decimal point at the start, followed by 3 6s, because that's like an approximation of 2 divided by 3, which is 0.6 repeating. Alternatively, you can also round the answer, and that's accepted too. So in the last example, it shows here for gridding in 2/3, it shows 0.6 decimal point 667, because that's another way you can round 2/3, and that's commonly seen in calculators actually. But yeah, continuing on here, as I mentioned in the example of 2.5, if your answer does not fill in all 4 spaces, that's totally okay. And this means that you can either bubble it in starting from the, you can either bubble it in starting from the right or starting from the right or starting from the left side. It does not matter. But what does matter is that if any spaces that you don't use in your answer, you leave blank. So for example, in this 201 here, the leftmost column is left blank, but then in the other example, the rightmost column is left blank. Nothing's bubbled in, nothing's written. Diego, you have a question? You can speak.
In none of these questions, it will be asked for us to develop or to like write a confirmation, right?
What?
In none of these questions, we have like to prove the answers or to write anything except the number, right?
Yeah, so for the math questions, you won't be expected to like prove or your answer or necessarily show your work. Although I do recommend writing out your work as you're solving problems. So that way, when you go back to check your answers, it's a bit easy. It's like easier for you to check and make sure you did your calculations correct. This here what I'm showing here right now is just how to fill in the grid in questions, the ones that require you to write a numerical answer rather than selecting one of 4 choices. But yeah, so you won't be asked to like prove your answer necessarily, but like it's best to like nonetheless write out your work so that you have an easier time checking and make sure it's correct once you've gotten all or most of your answers. So yeah.
Okay, and let's say that I get as a result 0.2. Should I write 0.2 or just 0.2?
Either one works really, just as long as you leave any spaces that you don't use blank. So like I mentioned, like for bubbling in 201, if they've started on the, if they put it on towards the right side, the leftmost column, the first one, has to be left completely blank. And likewise, if they started it on the leftmost side, then the final column, the 4th one, has to be left blank. So if you can bubble in 0.2 or 0.2, it'll work either way, just as long as you leave any other spaces in the grid question, in the grid answer box blank. Does that make sense?
Yes, thank you.
Of course. All right then. Well, moving on here. Let's see. So this part here is explaining like the calculators that you're allowed to use for the exam. So the only calculators that you're allowed to use for these are most graphing calculators, all scientific calculators, and all 4 function calculators, although it's very much not recommended that you use just a 4 function calculator. 4 function calculators are like those that have just addition, subtraction, multiplication, and division, and nothing else. Those are very much not recommended for the SAT because there's a very high chance you will have to use more complex functions such as like a square root or even trigonometric functions such as sine, cosine, and tangent. So very much not a good idea to use a 4 function calculator for the SAT, although it is allowed if you for some reason need to take one. And those are devices allowed, but various other devices such as computers, smart calculators with any kind of internet access or other smartphone-like features are not allowed. So that means like if they can like connect to any other device, be it through Bluetooth, internet, or something else, they're not allowed. And if you want a specific list of calculators that are allowed on the SAT, you can click this, you can open this link here, which is bit.ly/SAT calc-poll, which I'll go ahead and type in the chat if you want to save that too. So with that in mind, my personal recommendation for calculator for the SAT is either the TI-84 Plus or the TI-89, be it the regular one or the titanium. I've used both of these calculators not only in my SAT math exam, but also in my higher level math classes, and they work very well. So if you're like if you see the list of calculators and you're like confused on which one you should buy or which one might be the best, these are just my own personal recommendations based on my own experiences with using graphic calculators. But yeah, if you want to note, I'll go ahead and note those down in the chat as well. Yeah, CI-89 doesn't necessarily have to be the titanium version. But yeah, that's the one I had. But the other one works the regular TI-89 works just as well. Yeah. Continuing on here. These are some additional resources for studying. The top two here, I recommend the most by far. So Khan Academy is a free online resource for practicing just about, or like learning and practicing just about any subject you can think of, which includes SAT preparation. They have various like lectures and practice problems for you to do for the various sections of the SAT, not just the SAT with math portion, but it also has questions on like the reading and writing portions of the exam. So it's like by far like my most recommended resource for practicing and for the SAT. I've personally made plenty of use of it during my time before I started to take the SAT as well. So very much recommend. And the best part is it's completely free and there are no ads or anything of the sort. So yeah, definitely do check out Khan Academy if you want to practice for the SAT and practice the material that'll be on it. The other highly recommended resource I have here is the College Board. The College Board is the organization, the nonprofit organization that creates and administers the SAT exam, but they also have some additional resources for you to practice taking the exam. One of the most important ones they have, I believe, are the practice exams. They have a set of at least 10 different practice exams for you that you can download and print out and take for yourself. So like what you could do is you could download a given practice exam and time yourself for each of the portions and see how you do at the end of it. Like almost like taking an actual SAT, but on your own. They have many different practice tests you can do, along with explanations for these sorts of for the problems that you do. So if you're ever confused about it, you can consult that. You can consult the SAT practice exam as well because it explains it. And while I was talking about like if being confused on a problem and needing an explanation, I was also going to say that that's something you can also do in our SAT prep group chat on WhatsApp, which I'll be explaining more later. But yeah, these last three resources I don't recommend as much, mainly because they are mostly paid resources. They are like paid resources. You may not actually need to use them if you stick with Khan Academy or College Board, but these three resources do provide some like free SAT preparation material. So these are some resources to keep in mind if you're actually willing to like spend some money on like preparation materials, but chances are you may not actually need them. And especially if you may not have a lot of money, it's perfectly okay to not like use their paid material, especially because Khan Academy and College Board, they can very much get you far in preparing and improving your SAT score. So yeah, very much recommend the first two resources out of the rest of them here. You can go ahead and raise your hand, Diego.
If you had the choice to choose any of these, would you choose first Khan Academy or the Princeton Review or any other, independently of the cost?
I'd still go with Khan Academy personally because of the full extent of everything they have, but I honestly cannot speak to the quality so much of the paid resources of the other three websites that I mentioned. I'm just speaking about Khan Academy from my own personal experience using it for SAT prep, which is a very good resource and I highly recommend it. The College Board also is a good resource, but it's a good resource for a different reason than Khan Academy. while Khan Academy lets you learn and practice the concepts that are on the SAT, the College Board provides actual like practice exams that are in the exact same format as a real SAT exam. So it's like you can practice like what the full test taking experience with the College Board while you can also learn the concepts of the SAT on Khan Academy. That's why I recommend those the most.
Okay, thank you.
Of course. Also, welcome, Carolina. We were just going over some resources for the SAT. Since you missed some of the presentation earlier, I just wanted to mention that after next week, we will be uploading all of these SAT prep sessions onto YouTube, and you can get notified by joining our WhatsApp group, which I'll be presenting at the end of the presentation. So, yeah. Of course. We'll go ahead and continue now. So these are the 4 different areas of math that I mentioned earlier that will be like tested primarily on the SAT math section, mainly with the calculator portion. But yeah, you'll also see some of these types of questions on the SAT without calculator portion. So it's like you get to review this, you also review for the portion without calculator. So let me go over these brief descriptions here. So for the heart of algebra, this type of question focuses on linear equations, systems of equations, and functions. And they may ask you to create an equation that represents a situation. Like you may be shown a word problem, and you're going to be asked to describe what equation best represents the situation or something. So, and then it may also ask you to solve equations and systems of equations and make connections between different representations of linear relationships. If these concepts seem like confusing or wordy, it's okay, because we'll be going over each of these one at a time, including like the various like different parts of each area of math. So yeah. The next section that is tested on the SAT is problem solving and data analysis. This involves using ratios, percentages, and proportional reasoning to solve problems in real-world situations, including science, social science, and other contexts. And it also includes describing relationships shown graphically and analyzing statistical data. Now, I just wanted to mention that, but earlier I mentioned that these areas of math will also be tested on the SAT without calculator portion, but this problem solving and data analysis one is not so much present on the SAT without calculator section. It's mainly seen in the section with the calculator, which is what we're going over today. So you may not have to worry about this one as much for both exams, but it's nonetheless still like a good thing to learn about, because it will definitely appear on your SAT with calculator section. But yeah, moving on here, we have the passport to advanced math. This area of math focuses on the math you will need to pursue further study in a discipline such as science or economics, and for career opportunities in the STEM fields of science, technology, engineering, and math. The passport to advanced math area requires familiarity with more complex equations or functions, which will prepare you for calculus and advanced courses in statistics, like in higher education or in whatever career you may be trying to pursue, like mentioned previously. But yeah, these includes the kind of topics that may be introduced in like Algebra 2 and beyond, but you'll never see anything complex as calculus on the SAT. It goes only as far as pre-calculus, so you don't have to worry about like doing complex calculus integrals or anything of the sort. But yeah, the final area of math here is just additional topics in math, which are like miscellaneous areas that were not covered by the previous 3, and it may include topics like geometry, trigonometry, radian measure, and dealing with complex numbers. There's not too much to say about it besides it just being like a catch-all for any other topic that wasn't covered by these three. But yeah, with this, I'll be getting into each of the portions of areas of math and giving you practice problems to follow along and try in case you may not understand something, so I can also explain them. So to start, we have the heart of algebra. Like I mentioned, it expects you to know how to work with linear equations, expressions, inequalities in one or two variables, as well as graphs of linear equations. So let's go ahead and start with a practice problem here. This first one is a system of linear equations. And the problem is asking you, what is the solution x, y to the system of equations above? So it's asking you to figure out what x and y in this equation is. So I'll go ahead and give you guys a few minutes to work this problem out, and you can write your answer in the chat. And then afterwards, I will go over how to solve this kind of problem. So yeah. All right, I'm gonna give like a minute more for the other two people here to answer. All right, I think I'll go ahead and like explain the problem now. So the two that answered, Emmanuel and Diego, you guys got it right. The answer here is B, which means x is equal to 2 and y is equal to 7. So let me just stop sharing for a second while I look something that I can write on. Okay, now I'll go ahead and share my screen again. Okay, so the question, the set of equations we started with was the following: 6x plus 3y equals 33, and 6x minus y equals 5. Now, generally, there are two different ways you can solve a system of equations. The first one, and one that you may see more commonly, is that you have to solve for one variable in one equation and plug it into the other one, and plug the solution of that variable into the other equation to solve for the other variable. But there's an easier one that you can probably see that we can make use of here, which is to subtract both systems of equations from each other on both sides. And the reason we can do this is because 6x, there's a 6x term on both equations. So by subtracting all the equations from one equation from the other, we effectively get rid of this term, and we're left with an equation in one variable. So by doing this, we see 6x minus 6x is 0, 3y minus negative y, which means plus y, is 4y, and that is equal to 33 minus 5, which is 28. And from here, it's just a simple matter of solving the variable that's here, which is y. And we get, by dividing by 4 on both sides, we wind up with this solution for y. Y equals 7. Now that we have this solution, you can plug it in to either one of these two, but I'm going to plug it into I'm going to plug it into the second one since it's easier. And what we get as a new equation is 6x minus 7, because y is equal to 7, so we can put that in this equation now, equals 5. And to isolate x here, we add plus 7 to both sides, and we are left with 6x equals 12, and therefore from here we can just divide by 6 on both sides, and we get our final answer, x equals 2. And yeah, and from here you can, if you have the time, you may not have the time because of the SAT format, you could check your answer by plugging in your answers here to both of the equations and seeing if it evaluates correctly. So we can see 6 times 2 is 12, minus 7 is 5. So this second equation is indeed correct. Now, what about the first one? 6 times 2, since x is 2, equals 12, plus 3 times 7 is 21. So 12 plus 21, that equals 33. So this set of x and y is correct. So therefore, the answer is B. Now, one thing I don't recommend doing when doing these sorts of problems is, in case you don't know how to evaluate the problem for whatever reason, I would like to advise against trying a guess and check by substituting a given answer choice into the equation and seeing if it works out. Because you'll end up wasting a lot of time trying to do that, because you'll have to go through every answer, and you have to go through answers until you find a correct one. And especially if the correct answer happened to be D, like if the choice 2, 7 was answer D, that means you would have to guess and check 3 incorrect choices before finally getting to the last one. And that's very much a time waste. So I highly recommend that you can try and actually work the problem out instead of trying to do something like a guess and check, because substituting your answer and finding out it's wrong, it won't fly. It will take too much time. It's easier to actually work out the problem. And plus, it also gives you the additional benefit of making it easier to check your work. So yeah, these are one kind of question that you'll get most likely see on the SAT. A system of equations. I've seen them whenever I've taken the SATs. So yeah, very much recommend you become familiar with solving this sort of problem. But yeah, the next sample question we have here is an inequality. So this question here is asking, which of the following numbers is not a solution of the inequality 3x minus 5 is greater than or equal to 4x minus 3? So I'll go ahead and give you guys some time to work this problem out, and we'll come back together and I'll explain the problem. So I'll go ahead and give like a minute more for this problem. All right, I guess I'll go ahead and continue here. So the correct answer here is A, -1. Notice here, before I go to the actual explanation of the problem here, notice that it's asking here, which of the following answers is not a solution of the inequality? And that's an important thing because sometimes the SAT might try and trick you, like write it, like word a question in a tricky manner. And one of the ways they can do this is by using the word not. Because if you don't pay attention in reading the problem, you may end up selecting an answer that may be not what they're asking for. Like let's in this case, it's asking which of the following numbers is not a solution, and you may end up selecting a solution like -2, -3, -5. Either one, any one of those you could end up selecting if you're not paying attention to the problem, because it's asking for the solution that is incorrect and is not a solution of the inequality. So yeah, that's one of the ways they can trip you up is the use of the word not. So it's very important in doing the SAT with math that you pay attention to the wording that's used in word problems. So yeah, let me go ahead and get to explaining this then. So let me just erase all this real quick. Okay, so our problem we started here was the inequality 3x minus 5 is greater than or equal to 4x minus 3. Now, you can solve this equation almost exactly the same way as you would with, like as if this were an equal sign. So that's what we're going to do. So I'm going to isolate x on one side by subtracting 3x on both, because it's easier to do it this way than to subtract 4x from both sides. So we don't have to deal with an extra negative number. So we end up with -5 is greater than or equal to x minus 3. And from here, we can just solve for x by adding a 3 on both sides. So we end up with -2 is greater than or equal to x. You can flip this around to make it easier to read, but you also have to remember to change the direction of the sign here. So we end up with x is less than or equal to -2. And that's the solution to the inequality. All numbers that are -2 or below are correct. They're solutions to the inequality. Now, when we look at the problem, we see -2, -3, and -5 are all correct. They can all be used for x in this inequality, and it will be correct. But -1 is not less than or equal to -2, which means it's not a solution of the inequality. If you try to substitute it in here, it would be the results would be incorrect. Like -3, you get -3 minus 5 is greater than or equal to -4 minus -3, and this evaluates to -8 is greater than or equal to -7, which may look to be true, but since the numbers are negative, -8 is actually less than -7. So this is wrong. And that's how you know that A would be the correct answer here. Also, a quick thing to note about inequalities that you should make clear here, because it may not be as readily known, is that let's say you're trying to solve for x in some equation and you have a form like -x, like maybe -2x even. Like let's say you have something -2x is greater than or equal to 4. If you divide both sides or multiply both sides by a negative number, what ends up happening is that the sign, the inequality sign has to flip directions. So we cross that out and we simplify this. And our final solution to this little inequality here is x is less than or equal to -2. I can't give you a technical explanation as to why this happens, but it's nonetheless something to keep in mind if you happen to do any multiplication or division of both sides of an inequality by a negative number. If you're not using a negative number for your multiplication or division, you don't have to worry about flipping the sign around. But yeah, this is also something to note, since you may run into inequality equations on the SAT that involve you doing that, like division with negative numbers or multiplication. But yeah. And with that, we'll go ahead and continue here. This one is asking you to look at a graph, like a simple like XY graph. So this one is asking you to derive an equation of the line shown here. So what is an equation of the line L in the figure above? I'll let you guys go and work this out. All right, I just saw everyone actually has gotten the problem already. And yes, the correct answer is B. So I'll just show the general procedure of how to do this problem. So let me just go ahead and erase this. So we start with a line graph. No, I can't do that. That's fine. So we start with an XY plane here, and let me see how the graph looks. So it looks something like this, from what I remember. Okay, so the general procedure for finding the equation of this sort of graph is to usually try and find it in a form known as the slope-intercept form, which is what's used in the answer here. So the form is y equals mx plus b, where m is the slope and b is the y-intercept, which is the value of y that the line crosses the y-axis. So let's get into that a little bit. So the slope is defined as, it's usually commonly referred to as rise over run. But really what this is asking, it's asking for like, when x changes by some amount, how much does y change? So we can see this in the graph here. So let's look at this. When you go from x equals 0 to y equals 0, let's see, let's note these points down actually. So we start with the point, we start with this first point up here. The x coordinate is 0 and the y coordinate is 3. And then the second one, the x coordinate is 2, but the y coordinate is 0. So how can we make use of this? So we have to take the coordinates, the y coordinates of the second point in the line and subtract it from the y coordinate of the first one. So in this case, so like we have the first point and the second point. So we're asking for the change in value from there. So in the second point, the y coordinate is 0, and we subtract it by the y coordinate of the top of the first point, which is 3. Now for the run, we do the same thing that I just did here, but for the x-axis. So the x value of the second coordinate is a 2, and the x coordinate of the first one is a 0. So we end up here with -3 divided by 2. And that is what is known as the slope of the equation. The same principle applies, and it works no matter what 2 points of a graph you pick. Although it's better to work with something like this where they're clearly defined, because in the graph here, it's not immediately obvious what coordinate this is, what value is here, but we see 2 clearly defined points in the graph. So you can make use of those for figuring out the slope. Now, for the y-intercept, this one's easy. All you have to do is look at the y value of the line whenever x is 0. And we already have that point here, and we can see that y is 3. So that means b is just 3. So therefore, we get the form y equals mx plus b. Or wait, in that form, we get -3 over 2x plus 3, which is b. Now, here, let me just mention something real quick here. This is it's like a little shortcut that you can use if you have to like figure out an equation of like a line like this. One trick you can use is you can look at the graph and see which direction it's like pointing in. If it's pointing like if it's going from left to right, it's going top up to down. That means the slope will be negative no matter what. But if the line is going like this direction, then that means if it's going from like left to right, bottom to top, that means the slope is positive. And one way this can help you is you can use something known as the process of elimination to get rid of like answers that are clearly incorrect. So you have an easier time picking out a correct one. So through this process right here, we can clearly eliminate the answer D, because this implies that the line has a positive slope, which is not the case here because it's going in this direction. So that means the slope has to be negative. So that's one way you can make picking the correct answer a little bit easier and a little faster. So yeah, that is also something to keep in mind. But yeah, so next up is the problem solving and data analysis area of math. So this type of problem expects you to read and analyze data presented in either table or graph form, as well as understand ratios, rates, and percentages. You will be expected to know this. You will not be expected to know the subject of the data or specific statistical formulas, but rather be able to identify trends given some data. So if you're not going to be expected to know, like, let's say one of the questions is talking about some, maybe it's talking about the exports of some country and the amounts. You're not going to be expected to actually know specifically about that topic, but instead you'll be asked to like identify any trends in that data. And likewise, you won't need to know how to do like complex things like standard derivation or anything like that, which is like a statistical measure, a standard deviation. That's the one. Yeah, it's like a statistical measure in a data set. You won't be expected to know that. So yeah, and for the first example problem here, we have this table here showing the annual budgets for different programs in the American state of Kansas from 2007 to 2010. And you can see there's different categories like agricultural, natural resources, education, and so on, as well as the different year and how much was allocated to these. Now, keep in mind, something else that's shown down here is that it shows the annual budget in thousands of dollars. So that's something to keep in mind, because in answers, what may end up happening in the answers will probably be upscaled, will probably be scaled to be in the thousands of dollars. So like your final answer, like one of the options for your question or whatever will not show it like this. Like for example, 398,326. It's not going to show something like that. It'll show it with those extra 3 zeros from the 1,000 added. So it'll be 398 million rather than 1,000. Sorry if that's a little confusing, but yeah, I'm just trying to emphasize the point here that the data is presented in terms of thousands of dollars. So if you want to get the actual amount of money in the budget, you have to, like, if whatever value you're looking at, you have to add 3 zeros to the end of the number. But yeah, I'll give you guys a little bit for the 2 problems here, and then we'll get together and I'll explain how it works here. All right, I'll give like a minute more for this. Okay, I'll go ahead and explain these answers now. So, Diego posted the correct answers actually, and that both answers here are B and B. So the first one would be 65 million a year, and the second one is education. So let me go ahead and get to explaining this problem, and let me just screen grab this and paste it into the thing so I don't have to worry about the data. Okay, so let's look at the first problem here. This one is asking which of the following best approximates the average rate of change and the annual budget for agricultural and natural resources in Kansas from 2008 to 2010. So this problem is asking right now about these two values in particular. Now, so to make things easier, you're not going to be, for these kinds of problems, you don't really have to, for this kind of problem, you don't really have to you don't have to write and calculate the exact number. Like you don't have to do anything like 488,106 divided by subtracted by 358,708. You won't have to do any of that. Instead, what you can do is you can approximate using just these first three digits here. So you can look at 488 because it represents 488,000 in these figures, at least because remember it's in thousands of dollars, but we'll get to that later. So we can look at those first three numbers of both. So the way you do rate of change is you subtract the later number by the earlier number or the earlier figure. So we're looking at 2010 minus 2008's value. So when we do the subtraction, we get a value of 130. So this translates to 130,000 on this graph at least. But that means since this graph shows thousands of dollars, we have to add another 3 zeros after it, like that. And from here, since we subtracted the two big values, because that's the way a rate of change works. Rate of change involves the change in any y value divided by the change in time. So since we have here, we already did the change in the value of the budget. Now we have to divide it by the change in time. How many years has it passed? Because it's asking average rate of change. So the only measure of time we have is the years. So we can do that. So 2010 minus 2008. And that leaves us with 130 million divided by 2 years. And that gives us a total of 65 million per year. And that's the rate of change here. And that's why the answer is B. So yeah, when you're dealing with big numbers like this, you don't necessarily have to do the precise little calculations, like calculating right down to that last little single digit. You can just approximate with the biggest numbers first. So yeah, let me go ahead and clear this out so I can do the next problem. Okay, for the second problem here, of the following, which program's ratio of its 2007 to its 2010 budget is closest to the human resources program's ratio of its 2007 budget to its 2010 budget? So right now we need to focus on these two. We've focused on these two values because this will be a point of comparison for us. So we have here 4 million. About 4 million, basically. We can just, since we don't have to deal with the exact rate, we don't have to calculate the exact ratio, we can approximate it. And that's what we're going to do here. And an easy way to do that is just with the first digit because you can see here, this little 4 million, that 4 million number is a big step up from everything else here. So that's why we can just round it down and just treat it as 4 million right here. And we want a ratio with the 2010 value, which is about 5.9 million. But since we're focusing on just the first digit of the budget number, like how much it is and how much it is here, we can just go with we can almost go with the 5. But the thing is, since the hundreds, thousands digit is already 900, is already at 9, that means we can round it up and treat it as a 6 million instead, because it's so close to that value. Whereas 4 million is like nowhere, whereas 4 million here, it's like nowhere near 5 million. So we round it down. Likewise here, we round the 5.9 million up to 6 million. So what does that mean? That means the approximate ratio of human resources from 2007 to 2010 is about 2 to 3. So that's this ratio right here. This is the one we're trying to go for when we figure out which human resources program ratio of its 2000 budget to its 2010 budget is about the same as this. Now, I mentioned earlier how you shouldn't guess and really guess and check certain problems, but this is one of those where you might actually have to. But by doing this simple trick that I was talking about, focusing on like the biggest number first, you don't have to actually do much work in evaluating each of the possible answers. So to start, let's look at A, agricultural and natural resources. So what we have here is 373,000 over 488,000. Now, so if we want, we can focus on the biggest number here, and we can round it up as a result. So we can treat this as 400,000 over the number below. This can also be rounded up to the next highest 1,000. So 500,000 here. And this ratio simplifies to about 4 over 5 almost. Or if you want to be more conservative and not round at all, you'd still get a ratio of like 3 over 4. So clearly that's not exactly very good, because it's not very close to this one, to this existing ratio. So let's look at the other answers. Let's look at B, education. For education, we have 2.164 million over 3.008 million. Now, like if you focus on the biggest digit rather than anything else, you can round both of these down, and this gets us to 2 million over 3 million, because both of these numbers are too small to warrant getting to like round them up to the next million. And as a result, the ratio for this education one is 2 over 3. Now, this is virtually identical to the ratio that we determined earlier for human resources. So this seems like our most likely contender for the correct answer. But just to be sure, let's look at the other answers that we have here, like the other choices. So for highways and transportation, we have this. But this is like 1.468 million and 1.1773 million. Now the first one, the top one here, we don't really round. We can't really round it because it's not we can only round it up if you're like 1.5 million. So we just round it down to 1 million. And this one, since it's past 1.5 million, we can round it up to about 2 million just for the sake of convenience. And that gives us a ratio of 1 to 2. And that's not very close to 2/3. So we X that out. And lastly, we look at public safety here. These two values. So we get about 263K divided by 464K. You can do the rounding thing again by focusing on the highest digit, which is the 200,000, this one, and the 400,000 here. Both of these can be rounded up, so you can simplify it down to something like 300K divided by 500K actually. And this gives us an approximate ratio of 3.5, which again is not very close to this 2/3, unlike education, which was right on the spot. And through that, we can safely get rid of all these other choices and select B as the correct answer. But yeah, that's the kind of work you'd have. You may not have to, it may not be like this verbose in the writing. I'm just writing it out to like explain my line of thinking when I solve this kind of problem. Obviously, you may not actually have to write this much just for this little problem here, since most of it could be deducted almost like mentally by just focusing on those little single digits and stuff like that. So yeah. And with that, I'll go ahead and continue here. The next problem here focuses on percentages. So this one is saying Alma bought a laptop computer at a store that gave a 20% discount off its original price. The total amount she paid to the cashier was P dollars, including an 8% sales tax on the discounted price. So which of the following answers represents the original price of the computer in terms of P? So it's not necessarily asking here to solve for P, like the exact number, but it's asking you to represent the original price of the computer in terms of P. Like if you multiply P, if you like change P by this way, which one represents the original price? So I'll go ahead and give you guys a little bit to answer this. All right, I'll give like another minute for this. Okay. So yeah, let's for this question, the correct answer is D, as Carolina got correctly. So let me just quickly explain the line of reasoning for this because it's not too simple, it's not too complicated, but it's just a matter of understanding wording of percentage problems. So let's go and do that here. So we know that P represents the final price that Alma paid for their computer. So let's start with what it was saying here. So it's starting off by saying Alma bought a laptop computer at a store that gave a 20% discount off its original price. So a 20% discount in terms of percentages can be thought of taking 100%, like which is the original cost, minus 20. And that means that the remaining price that's to be paid is 80%, which translates to 0.8. So let's say since we're trying to figure out the original price of the computer, we can use a variable such as X to represent the original price. So we multiply the original price by X because Alma received a discount from the original price, so 20% off. So that means she paid 80% of the original price here. And then the next thing it says, the amount she paid to the cashier was P dollars, which we already set up here towards the end, because after all this here, she'll have paid P dollars. And it says, including an 8% sales tax on the discounted price. Now, this means that the sales tax means you add, rather than subtracting from 100% of like which represents the original price, you add a percent. So you get 100% plus 8% equals 108%. And this this means 1.08. A simple way to get like the numerical value of like a percentage is just divided by 100 because that's in the name. So when you divide 108 by 100, you get 1.08. And with that, you multiply this discounted price here by that number. So you get 1.08. And this in turn is what equals P. P is, so we have the original discounted price 0.8 times X, because the laptop originally cost X, but we have a 20% discount, so they only pay 80% of the price. And then on top of this 80% like of the original price, they have to pay 108% extra, or like 108% of it because of the additional 8% sales tax. And that's why we multiply this here. So, and that in turn all equals P. So from there, all you have to do to solve for X is just divide both sides by the these little numbers here, these extra percentages. So by doing that, we end up getting this X equals P divided by 0.8 times 1.08, because we divided both these numbers on both sides. So this ends up being the solution, and therefore the correct answer is D. Does that make sense? All right, I'm gonna.
Yes.
Okay, I'll go ahead and continue then. Just a moment. Now, this next section here is the passport to advanced math. And this category of question deals with the more difficult math questions, which is mostly material that's explained in that's taught in Algebra 2. And these include topics such as quadratic equations, nonlinear graphs, exponents, radicals, and other functions. So we'll get into this a little here. So this one's not so much a problem, but this is an explanation of quadratic equations because you'll probably run into these on the SAT. So quadratic equations usually come in the form of a times x squared plus b times x plus c equals 0, or in a factored form such as x minus n, which can be, and x times x minus m equals 0. Now, in these forms, a, b, and c can be just about any number. The only exception here is that a cannot be 0, because if a is 0, then this is it's no longer a quadratic equation. So a is never 0 in a quadratic equation, because like I said, if it were, then all you'd be left with is bx plus c equals 0, which is a linear equation. So yeah, and n and m are roots of the function, so of the quadratic equation, which I'll get into a bit. So that the roots, meaning, because if you, in this quadratic equation, if you substituted the value n or m into it, the whole thing would evaluate to 0. And that's usually the kind of thing that you'll be asked to do dealing with quadratic equations, like solving for them, like figuring out what values, if you plug them into this quadratic equation, will make the equation equal 0. And the way, and there exists various strategies to solve these quadratic equations through factoring, so that you turn this ax squared plus bx plus c into something that looks more like x minus n times x minus m. Because when it's in this factored format, you can easily see the correct solutions to the quadratic equation. It's just n or m. So, but the thing is, not all quadratic equations can be factored. The quadratic formula, however, can be used to solve any quadratic equation of this form, provided that a is not 0, because then, like I said, it's no longer a quadratic equation. So the formula presented here is negative b plus or minus the square root of b squared minus 4ac, all of which is divided by 2a. The plus or minus here is used to indicate that there's actually two solutions for x. One is where you add negative b to the square root, and one where you do a subtraction instead. So there's those two solutions. And what will usually happen when you apply this quadratic formula is you'll either get two like real solutions, like ones that are definable in the number line. You may end up getting only one solution, and that happens if the inside of the square root here is 0, and that's okay. Sometimes quadratic equations only have one correct solution. And the other possibility is that the inside of the square root here is negative, and that means the two solutions that exist for the quadratic formula are imaginary, meaning like if you were to graph that quadratic equation, it would never intersect the x line, the x-axis, because that's what's needed. That's what's needed in order to like have solutions. And that's another way you can solve for quadratic equations, is by graphing them and looking at where the graph intersects the x-axis. Now, these nonlinear graphs, these include graphs of functions like exponential, logarithmic, radical, and rational functions, as well as polynomial functions of degree greater than 2, which means that includes anything that can involve like x cubed, x to the 4th power, and so on. But you probably won't run into as many of those. But respectively here, we see the first type of equation here, the type graph here is for an exponential function, which is any number to the power of x. And as you can see, you'll probably have to do problems involving graphs like this. And the logarithm function is the inverse of the exponential function. And you can see its behavior. You can see like its behavior here for like this logarithm to the power of 2 of x. It's the inverse of this 2 over x here. Now, rational functions are basically just any function that has like two polynomials divided by each other. Usually the one on the bottom has a greater degree, which is like the highest exponent number, than the top polynomial. And there's a whole set of things to do it. There's a whole different properties of those types of graphs, but I can't really get into like full detail about how they work, but it is definitely something that is covered on Khan Academy. So if you're wanting more practice with these types of, if you want to learn more about and practice these types of functions, then you can do it on Khan Academy, because they definitely have resources for them. If not on SAT prep, then elsewhere on the site, because they also teach higher level math outside the SAT. And this last one here is just a graph of a quadratic equation, like I was talking previously. If you look at the graph, you can see that it intersects the x-axis at when x is 2 and -1, and that means those are like the solutions to the equation when y is supposed to equal 0. Those are the roots of the function. If this equation here were raised, like if there was that if that -2 there were a +2, then that would mean the graph never intersects this x-axis, and the solutions for the equation would therefore be imaginary. And it happens sometimes. There's no real solution to it, so you end up with an imaginary solution to quadratic equations. It's all fine, but yeah, that's something to keep in mind with them. Now, you may have to deal with exponents and radicals as well. So there's a little problem here on the left. It's asking you if x, or 2 to the power of x plus 3 minus 2 to the x equals k times 2 to the x. What is the value of k? I'll give you guys a little bit to try this problem out. It's a little bit more complex than the other ones I've been showing. But yeah, you can go ahead and give it a try. I'll give another minute for this. All right, I'll go ahead and go over this problem now. So Diego tried answering it here, saying it was 8, but the correct answer here is actually 7. It's very close nonetheless, and I can see why people would get it mixed up. So I'll go ahead and explain it here. So the original equation we were given here is 2 to the power of x plus 3 minus 2 to the x is equal to k times 2 to the x. Now, one of the properties of exponents that we can make use of here, given an exponent a times b plus c, this can be expanded into a times b times a to the power of c. This works. These are functionally equivalent. You can either use this to expand it into these two terms, or you can combine two terms like this. In our case, it'll be useful to expand it into those two terms with this one. with this 2x plus 3 to the x plus 3. And when we do that, we wind up with something looking like this: 2 to the x times 2 to the third power minus 2 to the x equals k times 2 to the x. Now, we can see on the left side, there is a common, or actually on everywhere, we can see there's a 2 to the x in every single term. So what we can do is divide everything, is divide all the terms by 2 to the x to get rid of it, basically, because we're not trying to solve for x here, we're trying to solve for k. And we don't actually need 2 to the x here to solve it. So we can simplify it by just doing that. And this gets rid of it everywhere. This whole thing here, this 2 to the x divided by 2 to the x simplifies to 1. So keep that in mind. It's not like you're completely getting rid of the term, like getting rid of this little term here. It just becomes 1. So we end up with 2 to the third minus 1 equals k. Now, 2 to the third, that's 8. So we end up here with k equals 7. So that's why the answer is 7, not 8 necessarily. But I get the line of thinking I could get someone to answer 8 instead. It's just the kind of thing you have to like be careful about. But these rules here and these radical rules here, like the kinds that are used for square root, cubic roots, quartic roots, and so on. Yeah, these are also something that will be covered on Khan Academy and other resources that when you practice the SAT. I don't think you'll have to do too many problems with these, but they're still very good. They're still pretty good to know nonetheless. So, yeah. So this last little bit here, I'm just going to go over briefly because there's not as much to it. These are the additional topics in math, and they cover other math topics not presented previously. And they generally include problems about geometry, trigonometry, and angles, which are the kind of stuff that's on your answer sheet for the math test. So the first little thing I have here on the left shows the 3 most basic trigonometric functions, which are sine, cosine, and tangent. These all apply to a right triangle, like an angle of a right triangle. So as you can see, the triangle used for the demonstration has a right angle, and there's another angle theta here, which is what we're going to be using to define these functions. So a sine of this angle of theta is equal to the side, the length of the side that's opposite of the angle theta, right here. The length of this divided by the length of the hypotenuse, the longest, which is the longest side of this right triangle. That's what it means. The cosine of angle theta is the length of the side that's adjacent to the angle theta here, right here, divided by the length of the hypotenuse. So it's like the counterpart to sine. And tangent, tangent's a little different here. It's defined by the length of the side that's opposite angle theta divided by the side that is adjacent to angle theta. There's no hypotenuse involved here. So that's that, but tangent nonetheless is a very important function. Tangent can also be written in terms of sine and cosine. And if you do this, the tangent of angle theta can also be written as the sine of angle theta divided by the cosine of angle theta. So that's another way to think about tangent if you want. And this last little bit here is about similar triangles. I'm not going to go into these too much because you probably won't have to run into them. You probably won't run into them as much. But if you would like more practice with them, they're definitely something that would be covered on Khan Academy, identifying similar triangles and the like. So yeah, let me go ahead and continue here. So what advice do I have for this SAT of calculator test? So the first big one I have here is to do practice tests. And as I mentioned in the resources slide, there are many practice tests available on the College Board's website. And there's an easy link to it here, so you don't have to like look it up. look it up by going to the College Board website and navigating around. You can just go and access the tests with the link I just sent in the chat. You can just click it and it will take you right to the College Board page where all of their practice tests are available for you to download. So I highly recommend that you take practice tests and time yourself on all the different portions so that you can get that experience of what the actual SAT will be like in regards to timing, and it'll help you practice time management for each of the problems on the SAT, because some might take a while and such like that. So you need to know how to manage that sort of thing. The second thing I have to say here is, and I've been saying, is to practice math concepts on Khan Academy. And like I mentioned before, there are also resources specifically created for the SAT math portion, both with and without the calculator. The other piece of advice here, I have to say, is a bit I guess it's a bit different from what others may say, but I personally don't recommend that you be too over-reliant on your calculator, because if there is some calculation that you can easily do mentally, you should, or like with minimal writing and stuff, you can do that instead of having to enter it into your calculator, which wastes time because you not only know how to do the problem, but you also have to waste the time to enter it into the calculator and stuff like that. And this last bit is just general test taking advice. It doesn't just apply to the SAT math. It applies to any portion of the SAT and any test really. But if you're struggling with a problem, you should skip it and move on to the next and look at it back at it later. Because if you spend all your time stuck on one particular problem, you waste time that could be spent answering more questions later in the exam that might be easier and could get you more points on the exam. So it's best to do that. If you're stuck on a problem or you're confused by it, just mark it and skip it and go to the next one and continue on. And then when you have time, like after doing the rest of the problems that you can try and go back to the problem and see if you can figure it out. Or worst case, you might not get to answer it, which is okay, because incorrect answers on the SAT won't penalize you. Like, you won't lose points for getting a problem wrong. You just won't get any additional ones. So keep that in mind when you're taking the SAT, especially the SAT with math, because I feel like in those cases, in this test, there may be more problems like that where you might struggle and you might need to like continue to the next problems. But honestly, I feel like you guys will be fine. You guys did pretty good on the questions that I presented today. So you're already on the right track from what I can see here. So I want to say good job to you all. You guys are doing good today. So yeah. We're now getting close to the end of our sessions, ending a little bit early, but that's okay. I want to bring up the WhatsApp study group that I mentioned earlier. This is where we will notify people about the SAT prep sessions being uploaded to YouTube, as well as a place for you to ask either me or the other intern, Danielle, any questions you may have about the SAT or a specific problem on the SAT from any portion of it. So it can be anything from the reading, from the writing, or from the math sections. You can ask us any question about it. So let me just send the link in the chat so you don't have to type it and you can just click it. So click this link and you'll be taken to our WhatsApp group. And yeah. I'm assuming you are leaving now, Carolina. That's okay. I was just gonna for the last bit of this presentation, I was just gonna advertise our final SAT prep session next week. So next week, we'll be going over the math without calculator portion, which, although it's pretty similar to this one, there's some more additional stuff to know about it, but we'll be hosting it next week on September 5th at the same time on Monday at 4 p.m. Central Time or Mexico City time. So in the off chance that you're not registered for this event already, there's the link to do it here, and I'll go ahead and type it in the chat as well, so you don't have to type it by yourself. So you can just click it and be taken to the registration page if you want to attend next week's SAT prep sessions. But yeah, Are there any other final questions that you would like to ask about this?
No, I have none. I'd like to thank you for explaining everything to us and making it clear. Now I don't feel so intimidated by the SAT calculator math session. And thanks.
Thank you. I'm glad to hear that. I'm glad to hear this was helpful for you too. With that, I think we'll go ahead and wrap up today's session. I'd like to thank you all for attending, and I hope I can see you all next week for the final session of the SAT prep. Thank you, everyone. You're now dismissed.